Okay, hi everyone. We're going to move on to part two. And in part two, we are going to create a density attribute on our grid. We're going to source some density into the grid in a sphere, and then have that density track along with this velocity field that we created that has the curl noise. And that tracking of the velocity field is called advection. So we're going to use some pre-built modules that do that. So the first thing we need to do is in our init, we want to create a new attribute, and we're going to make a float. Instead of particles, we're going to make it stat context, and we're going to call it density, and we're going to make it 0. Okay, so now that we have two attributes here, we need to start worrying about the indices of these attributes. So the indices are just a way to sort of refer to an attribute by a tag that's not just the name of it and the string that represents that. So it's just an integer that represents where that lives in the actual data structure that has all the information about the attributes. So we need to do a little bit of work to set ourselves up to use these attributes more generically moving forward. So in emitter spawn, we're going to create some new parameters, and we're going to make two integers. The first one we're going to call density index, and the second one is going to be called, you guessed it, velocity index. And so what we want to call is grid3d get grid index from name. And the grid is an obvious one, and the grid name is density, and we're going to do the same thing for velocity. Specify the grid, choose velocity. Awesome. Okay, so the next thing we're going to do is on this visualized vector field, if we want this to work in the future, we need to make sure we make the vector index now. So the index of the vector attribute we care about is velocity index. And if we play, you'll see it still works as we expected. Cool. All right, the next thing we want to do is we need to have a way to render this density. Even though it's 0 everywhere, we want to have the ability to render it as if it were smoke, essentially. So we're going to create a new renderer. We're going to make a mesh renderer. And under meshes, we want to choose this mesh. So it's S cubed 1 centimeter flipped normals. And this is just an inverted normal bounding box that will be sized according to how big the grid is and placed in the world where the grid is. So when you have this rendered, you're only going to have one for the entire system rather than it being spawned once per grid. Like a lot of times when you have a renderer, you get one per particle, right? So you'll have like 100 particles, you'll have 100 meshes or 100 sprites. In here, we're only going to have one. So it's important to make the source mode emitter. That makes sure that we only ever have one mesh. Okay, then what we want to do is start to fill out some of the parameters on this renderer so it connects to all the important attributes of the grid. The first most important one is on scale binding. We want to make sure this goes to world grid extents. Okay, next up we want to add some overrides on the material parameter bindings. Actually, before we do that, we need to set what material we're using. So enable material overrides, add one, and here we want to use raymarch smoke inst. So that's an instance of a raymarching material that just does some smoke. And so raymarching is a process of rendering where for every pixel you kind of step through the volume and accumulate how much smoke there is so you can render it from some viewpoint. Once we have that set, we're going to start making these material parameter bindings so we can send all of the data we need to the material. Okay, the first one, we're going to go right down the list here of the important ones, is volume text. So that's interesting. We need to have this volume texture, and we need to set it to some Niagara variable. And so the way this works is, what we're going to do is fill up a volume texture, and then from our simulation data in the Grid 3D collection, and then send it to the renderer. So in order to do that, we need to make a new attribute, and we're going to make a render target 2D, and we're going to call it RT. And we're going to drag RT into emitter spawn. We're not going to set size here. What we're going to do is call grid 3D init RT. We're going to pass in RT. Oops. Oh shoot, I created the wrong render target. Sorry, hold on one sec. My bad. We are going to create a render target volume, call it RT. I created the 2D version by accident. And so we're going to drag that in above the init RT. Not going to change anything here. We're going to attach it here in the RT, and then the grid here is just the same grid we've been doing. So this makes sure that the render target is the same resolution as the grid. And the next thing we want to do is fill that render target with some data. So this will be an RGBA texture that we can put any of the attributes that we've defined in here into this render target. So in presim, or actually, you know what? We're going to just keep going along here. We're going to make a new stage. And in that stage, we're going to call it postsim. We're going to set it to data interface. We're going to do grid, and we're going to do, we are going to do set the RT values, so grid 3D set RT values, and the grid is grid, the render target, and so this lets us set the RGBA values for that render target. And so what we're going to do is we want to make red density. So we'll press a little down arrow and choose emitter.grid.density in the red channel. We know that the red channel is what the material is looking for density. Okay, so now we have this render target all set up, and we need to go back to the renderer, go back to our material bind and say, okay, the volume texture that this material cares about is RT. That's the render target that connects up to the texture. So unfortunately, that's not enough. We need to put more stuff in here so everything is working correctly. So we'll make another one, and this time we're going to do voxel size. So voxel size is just the length of one edge of your grid in world space, and we need to create a new variable for that. So what we're going to do is go up here, and in emitter spawn, we're going to make another variable. This one's going to be a float, and we're going to call it dx, which is just kind of the common nomenclature for the size of a cell. And we know that the Grid 3D set resolution outputs the world cell size. So we're going to do a float from vector, and we're going to choose the world cell size vector that the set resolution outputs. Okay, and we're going to only take the X channel because we know that these voxels are all cubes. So the world space size in each dimension is the same. We're just going to take it in X. We're going to assign that to dx and go back to the renderer. And we're going to say, well, now voxel size is dx. And then we have a couple more to fill out. World grid extents, we know what that is. World to local 0. Okay, so here we have 4 attributes you can see that this material cares about. World to local 0, 1, 2, and 3. So these are just vector 4s that are slices of the world to local transform that we're computing in this emitter. And because we can't pass matrices as one single parameter right now, we break it up into 4 vector 4s. So we're just going to fill out each one. And we know that we have this already calculated. And as we do this, just note that the world to local transformation, oops, I chose local to world here. That's not going to work. World to local transformation is the transformation that goes from some oriented space in world to the local space for the grid, which is just the size of the grid in world space, but centered around the origin. Okay, 2 more. World to local 2, world to local 2, and world to local 3. World to local 3. Okay, now that we have all of these set up, we have pretty much everything we need in order to render this. And what we're going to try to do is first set some value on density that we actually care about. So in order to do that, we're going to go into presim and we're going to just make a new set. And we're going to turn off the velocity field visualization. We don't care about that right now. And we're going to drag in the density and we're going to make it 1. And so if we play, we're not getting anything. That's okay. The density is 1, but we don't have any lights or anything, so it's going to be just black. We know that this material in the green channel has the lighting information, so if we just make that 1, we're going to see something. And it's just going to be this cube. And you can see there's some artifacts from the rendering, which we can deal with some other time. Right now, it doesn't really matter. But this is just sort of the basics right now. Okay, so what we've done so far is created this renderer and attached some density to it, and we're volume rendering the density, this new attribute that we have on the grid. And the next step will be to do something more interesting with this and get some dynamics in there. Great. Thank you.